I'm going to rewrite the quadratic formula up here as well. And first of all, whether you're using the quadratic formula or factoring, that can only happen if your equation is equal to 0. So the first step is we would need to move the 1 over to make it equal to 0. Now, as far as factoring goes, if I were going to factor this, it is a little bit harder because the first ones have to multiply to give you 6 sine squared. And there's some options. It could be 3 and 2, or it could be 6 and 1. Okay? The last ones need to multiply to give you 1, and there are no options there. The only way you can multiply to get 1 is if you have 1 and 1. So when I'm factoring this, I'd probably start with the last ones being both 1s, if it's possible. And then I look at my first ones and decide, should 6 and 1 or 3 and 2, what's going to work better? Well, I need to get plus 1 as my middle term. So 3 and 2 seem to work better because they have a difference of 1. In the end, I want a plus 1, so I'm going to make my outside plus 3, my inside minus 2. If I multiply that out, I get 6 sine squared plus sine theta minus 1. So it works perfectly. Okay? But sometimes it seems like no matter what you do, you can't seem to factor. In that case, you could use the quadratic formula. And I'll do that at the end if that was the case. If you were unable to factor it, how can you use the quadratic formula to get you the same thing? But at this point, we factored it. It's equal to 0. So here on this side, sine of theta would equal 1/3. And on this side, sine of theta is equal to negative 1/2. Only one of these is on your unit circle as far as a value that you've memorized. We know that negative 1/2, 1/2 appears when your reference angle is part of your pi over 6 family. And if it's negative, you'd be looking in quadrants 3 and quadrant 4. For 1/3, it's not on your unit circle, so you have to go back and do it the same way that you would solve it back in grade 10 and 11 using your calculator. So you take out your calculator, and I'm already in radians. I would go sine inverse of 1 divided by 3 to find my reference angle. 0.34. So I could write down that my reference angle is 0.34. Because sine is positive, I know that I'm looking in quadrant 1. Or quadrant 2. My angle in quadrant 1 will be the 0.34. And if I had that same reference angle of 0.34 in quadrant 2, how do I find this angle? Well, all the way would be pi minus my reference angle. So I go to my calculator, I type in pi minus 0.34. And you get 2.80. So in this question, we have these answers which are exact values, and these answers which are estimates. So let's say you were unable to factor, but you saw on your formula sheet that you had the quadratic formula, and your quadratic formula is x equals blah, blah, blah. That is the quadratic formula whenever you have, and they have this on your formula sheet as well, ax squared plus bx plus c equals 0. So whatever's in front of x squared is your a value, whatever's in front of x is your b value, and whatever's a number all by itself is your c value. Now the first difference for solving a trig equation as opposed to solving this equation has x squared. What do we have squared? We have sine squared. So starting off with the quadratic formula, instead of writing x equals, you will start off by writing sine theta equals negative b, so what's our b value? It's a 1, negative 1 plus or minus b squared, which would be 1, minus 4 times a, which is 6, times c, which is negative 1, over 2 times a, which is 2 times 6. Simplify this a little bit. Negative 1 plus or minus. Here I'm going to get 1 plus 24, which is 25, over 12. The square root of 25, negative 1 plus or minus 5 over 12, which means one answer is when you add 5. Negative 1 plus 5 will be 4 over 12, which reduces to 1/3, which should make you realize that matches up with this one. And if you subtracted 5, you would get negative 6 over 12, which reduces to negative 1 over 2, which matches with that one. So at this point, you could have said sine of theta equals 1/3, or sine of theta equals negative 1/2. If you can factor, often it's quicker. But if you can't factor, the formula is quicker. And then from that point, you'd solve it exactly the same as we did on the left-hand side. Sometimes they design a question that can only be done with the quadratic formula. You can't factor it. You can't solve it any other way. As far as some pattern things, whenever this works out to a perfect square like it did here, square root of 25, which is just 5, anytime it works out to a perfect number like that, at that point you said, oh, I could have factored it. If that number is perfect, it means that you could have factored it. If that number is something you can't take the square root of, then you're like, good. The only thing I could have done was the quadratic formula.